Yes, we made it to the free response questions. There's going to be 4 of them on the AP exam, and usually each problem has like 5 or 6 parts to it, and this is not going to be any different. You'll have problems on trigonometry, data modeling, calculator problems, non-calculator problems. This is problem 1. This is a calculator problem, and this is data modeling, so this is 6 parts, I believe. Let's just jump right into it. Consider the function h of x as depicted in the provided table. So there you go, with a domain consisting of the values 1 and 2 and 3 and 4 and 5. Additionally, we are presented with another function, j of x, defined by j of x equals 5 log of x. So we'll probably need our calculator for a lot of these. Define the function k as k of x is j of h of x equals j of h of x. Determine the value of k of 4 as a decimal approximation or specify if it's undefined. When would it be undefined? Like if x is negative or something like that. So let's see what we need. We have k of 4 they want. Okay, and again, this is part I, part 1, part I. K of 4, I'm going to use this version of it, equals j of h of 1, and let's get different colors because I can. So let's see what we have. H of 1 is found by taking the 1 in this guy and saying, oh, well, 1 maps out to 7, so h of 1 is 7. So this becomes j of 7. Now, how do we find j of 7? We're going to need our calculator for this one. So j of 7 is going to be 5 log of 7. Now, by the way, just in case I haven't said it or you haven't noticed it, this is invisible base 10. So yeah, you could pretty easily plug this into your calculator, and that's what we're going to do right now. All right, 5 log 7. Again, the log that we saw in the problem is the same log that we see here, invisible base 10. Going to get a pretty terrible number, 4.2254, so 4.225. Remember, when we do these, we round to 3 decimal places. So 4.225. Let's go back and write that out. All right, so k of 4 is going to be roughly 4.225. So that's it. That's all we have to do. Now, again, I know I said it in the calculator thing. Since this is an open-ended, we have to make sure that we round to 3 decimal places. So this is our approximation rounded to 3 decimal places. So that is part I. Now, part II, or E for Joel Embiid, because he has 2 I's in his name, Philly fans? Determine all values of x for which h of x equals 7, or specify if no such values exist. Now, the h is this guy. So, what x values give us h of x equals 7? Well, there's 2 of them. Now, this is not saying, hey, let's plug in 7. No, this is saying this is h of x equals 7 right here. So your 7 and your 7. So what x values seem to do that? 1 and 5. So x is going to equal 1 and 5 for this guy right here. Okay, so no calculator. This one was one of the simpler ones, so I'll definitely take it. Okay, problems 1 and 2 of part A complete. Now let's take a look at problems 1 and 2 of B. Consider the function h, it's the same thing, I don't know why I'm reading it. Discover all the values of x as decimal approximations for which j of x equals negative 7.5, or indicate if no such values exist. So this is me taking the j guy and replacing j of x with negative 7.5. So negative 7.5 equals 5 log of x. So what I need to do is solve for x here. Well, x is trapped inside of a log. All right, x is trapped inside of a log, so what I have to do is I need to get log all by itself so I can get x all by itself. So if I divide both sides by 5, that gets the log all by itself. Okay, so this is actually -3/2. Now, if you didn't know that, this is a calculator section. By all means, use a calculator. You can write that out as negative um, 1.5, but I'm just going to keep on going. That's going to equal log of x. Now, again, log of x means invisible base 10. If I want to get x all by itself, I can take the 10 to the of both sides. Bad grammar? Absolutely. You could just write this out in exponential form, but I prefer doing it this way. So x is going to equal whatever 1 over 10 to the 3 halves is. But what it is it's not going to be a pretty number. At least I don't think it is. I mean, no, it's not going to be a pretty number. I'll just stop right there. So let's run to our calculator and find out what 10 to the -3/2 is. So 10 to the -3/2. The nice thing about these guys is it actually gives you 10 to the right in front of log, or right with log. I wonder why. -3 divided by 2 is going to give us 0.0316. So 3 decimal places is 0.31 or 32. 0.032. I don't know if I said that correctly, but that's what we're going to write out. 0.032, that's going to be our guy. 0.032. And if you're wondering why is it so ugly, well, when you have a number taken to a negative exponent and that negative exponent is greater than 1, it's just not going to be the prettiest thing ever. This is asking you 1 over 10 cubed, but then take the square root of 10 cubed. So 1 over the square root of 1,000, big number. Okay, so 1 over a big number is going to give you a small number in the end. Now here's where we have to just double check things. Can I take this, since this was j of x, plug that in, can I take 5 log of 0. Blah, blah, blah? Yes, I can take the log of any positive number as long as it's not 0, as long as it's not negative. This is awfully close to 0, but it's not 0, so this will work just fine. Okay, so yep, this is allowed. Values do exist. I get one answer, and that's my one answer only. Now it's 2. Ascertain, that's a word you don't see often. The end behavior of j of x as x increases without bound. Express your answer using the mathematical notation of a limit. Now, if you need to graph this out, go ahead, be my guest, graph this out. Go to y equals 5 log x. The reality is this is nothing fancy at all. This is a log function multiplied by a positive number, which means it's just going to be a warped version of a log function. Log functions look like this. Okay, everything, remember what I said a second ago, you're not allowed to have negatives, you're not allowed to have zeros. So a log is going to hover awfully close to the y-axis and then go like that. It will never at any point touch the y-axis. It'll never cross the y-axis. It's always going to stay to the right side. Okay, so the end behavior of one of them is going to be obvious. As we move to the right, as we increase without bound, this is going to continue going up and to the right. So the right side, okay, the limit as we keep moving to the right, the limit as x approaches infinity of j of x is going to also be infinity. Okay, if you're wondering, well, won't that flatten out somewhere? No, it will never flatten out. Now, what's going to happen is, yes, this will continue to get flatter, but it'll still keep going up and to the right. It'll never at any point stop going up and to the right. Okay, it'll really do it slowly, but this will continue going up and to the right, meaning that it'll be infinity. Now, if you're thinking, all right, the limit as x approaches negative infinity, you're wrong. See, we can't go to negative infinity. We can't. I mean, we keep going left, and we hit this roadblock right here at the y-axis. So the y-axis, we can't go any further than that. In fact, since the y-axis represents an x value of 0, we can't even hit the x-axis. But what we can do is we can approach that 0 from the right without actually touching it. So we're going to say the limit as x approaches 0 from the right of j of x. Now, as we approach 0 from the right, we're going down, 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 down forever. Okay, and this kind of is obvious here as we have a small x, we're hitting negative numbers. So this is going to be negative infinity. Okay? So that's the end limit of a logarithmic function. Remember, the end limit of logarithmic functions are never going to be limit as it approaches infinity and as it approaches negative infinity. You're going to have to hit a roadblock somewhere, and that's what we did with this guy. All right, so part B, dendo. Let's do part C. Consider, I keep doing that. Determine if H possesses an inverse function. All right, I'm going to tell you this and tell you this right now. When I was looking at the practice examples of these, you are not allowed to say it fails the horizontal line test. Now, if you're like, whoa, what's a horizontal line test? If I were to graph these points, right, I get 1, 7, 2, 4, 3, 1, 4, 4, and 5, 7. Okay, now you know what the vertical line test is. The vertical line is you draw a vertical line, you pass it through your function, and if your vertical line hits a spot more than once, it's not a function. So if we were to flip this sideways, which it would be, like the inverse of this would be dots going like this, okay, because you would just flip the functions. I'm sure we're going to do that at some point. If you're thinking, oh, well then, if we were just to make believe that this is going to turn into this, why wouldn't the horizontal line test hitting two dots not be good enough? I don't know. But for whatever reason, you're not allowed to say it's invertible because it fails the horizontal line test. You're not allowed to say that. So what we will say is we will say something like this. Okay? We have the 5 points of H inverse of X will be, and I'll just take these and I'll flip them around. So it's 1, 7, 2, 4, 3, 1. In order to find the inverse, you literally swap the X's and your Y's. So our 5 coordinates will be 7, 1. Maybe I should say coordinates instead of points, but there's nothing wrong with saying points. It just sounds more professional, I guess. 1, 3, 4, 4. And 7, 5. Since an x value of 7, I'll just say since an x equals 7 is not 1 to 1, H inverse of X is invertible, or is not invertible. Okay, so again, it's not good enough to say, I did the horizontal line test and the horizontal line test failed. You have to explain what it means for the horizontal line test to fail. 7 maps to 2 different numbers after I flip them. 7 maps to 1 and 7 maps to 5. A function cannot map to 2 different y values. Therefore, H inverse is not a function, which means it's not invertible. I don't like it. I don't like that the people decided that, yeah, not good enough, friend. Don't like it. But that's what they decided, and I can't help it. I don't make these tests. Now, I make this test, but I can't make these tests. So something to look out for. Provide rational, you're kidding me. So all I had to do for 1 was just say, no. That's really annoying. So let's try this again. And this is a good learning experience because by drawing a rough draft, it allows me to maybe write this a little bit better. So I'm okay with this. Determine if H possesses an inverse function. It doesn't. Okay. End sentence. Now, what does that provide a rationale for your response to this one? All right, let's word this better. 5 points, or 5, I didn't like the word points last time, so I'll change it to 5 coordinates of H inverse of X are, and I'll write it out as again, 7, 1, 4, 2, 1, 3, 4, 4, and 7.5. Now, I want to expand a little bit on what I said. The point, or the x value of 7 maps to both 1 and, what's the other one? 5. Therefore, H inverse is not a function because it is not 1 to 1. Okay, this one's 1 to 2. And you could have used the 4s if you wanted to as well, but I like this explanation a little bit better. So a blessing in disguise. And also, as I started to write this out, I realized I was running out of room and I kind of wanted to rush my description. So I'm happy with this. But this is an example of what a problem could look like. You have some modeling, you have some inverse stuff, you have some other stuff, some calculator stuff that we had to deal with. Not all calculator, just a little bit. But, you know, something to expect. All right, so that's problem 1. Hope this helps.